Intelligent girls and smart boys, how are you? I hope you are fine at your home. In the last session, we have discussed about properties of multiplication. In today's class, we are going to discuss about properties of division. Okay? First property, we are going to see closure property. You know what is the closure property? Closure property means you have to take two elements and then you have to apply that operation. The result should be the integer. Okay, see here, I have taken two integers 10 and 2. I am dividing 10 by 2. I get the answer as 5. See the second example. I have taken minus 15 and 3. I am applying the operation division, that is dividing minus 15 by 3. I get the answer as minus 5. Thus, I am taking two integers, applying the operation division. I get the result as an integer. See the third example, 5 by 12. If you divide the 5 by 12, we get 5 by 12 or the answer should be in the decimal. Definitely not be an integer. Thus, we can say if you take two integer and we apply the operation division, we may get integer or may not get integer. So, we can say integers are not closed under division because suppose if you are passed in all the subject and you are failing one subject means the rank should not be issued to you. Like that, the result is sometimes integer and sometimes it be a not an integer. So we can say integers are not closed under division. Okay. Next property is commutative property. Okay. Commutative property means you have to take two elements. Okay. First I am taking 12 divided by 4. Next that we have to change the order of division. First by dividing 12 by 4, 1 4 is 4, 3 4s are 12, 3 by 1 equal to 3. Let it be equation 1. Now we are going to reverse the number. That is 4 divided by 12, 4 by 12, 1 4 is 4, 3 4s are 12, 1 by 3. Let it be equation 2. Thus from 1 and 2 we can say is 3 is equal to 1 by 3 children. No, it is not equal. Thus we can conclude from 1 and 2, 12 divided by 4 is not equal to 4 divided by 12. So we can easily say that integers are not commutative under division. Okay. In your book, exercise 1.2, question number 3, subdivision B, they are asking the example for commutative property for division. So you can give this example or you can use the sum of the numbers to explain the commutative property for division. Okay. See the next property, associative property. Associative property means you have to take three elements, one operation. Okay. Here I have taken three elements, 24, 8, 2. And the operation is division. First I am choosing first two integers, that is 24 divided by 8. 24 divided by 8. 1 8 is 8. 3 4s are 3 8s are 24. Thus 3 by 1 is equal to 3 divided by 2. That is 3 divided by 2. Let it be equation number 1. Next I am choosing second and third integer first. See here what happens. 24 divided by 8 by 2. So 1 2 is 2. 4 2s are 8. That is 4 by 1 is equal to 4. That is 24 divided by 4 is equal to 24 by 4. 1 4 is 4. 6 4s are 24. 6 by 1 equal to 6. Let it be equation number 2. Now compare the equation 1 and 2. Here we have chosen the three integers. First here we operated first two integers here. Here we operated the second and the third integer first. But we get the different answer. So we can conclude from 1 and 2, 24 divided by 8 divided by 2 is not equal to 24 divided by 8 divided by 2. Thus we can clearly say division is not associative for integers. Thus for the operation division, closure property does not hold, commutative property does not hold for integers, and associative property also not hold children. Okay, let us take the distributive property. For multiplication also we have the distributive property. But for the addition, subtraction we don't have this property. Why? For distributive property we need three integers and two operations. Here we have taken three integers and two operations. What are the two operations? Division and addition. While in the case of multiplication, here we have taken multiplication and addition here. But in the process of division, that is the properties of division, here instead of multiplication we are taking division here. It's clear children? Thus 24 divided by 6 plus 2. First I am evaluating 6 plus 2. 6 plus 2 is 8. That is 24 divided by 8. 24 divided by 8. 1 8 is 8. 3 8s are 24. 3 by 1 which is equal to 3. Let it be equation number 1. Next I am taking, that is I am distributing this division over this addition. That is 24 divided by 6 plus 24 divided by 2. Let us check what happens. Okay. 24 divided by 6, that is 1 6 is 6, 4 6 are 24, plus 24 divided by 2, 1 2 is 2, 12 2s are 24. Thus 4 by 1 is 4, 12 by 1 is 12. 4 plus 12, what is your answer? 16. Let it be equation number 2. What is your equation 1? 3. What is your equation 2? 16. Is 3 is equal to 16 children? No. Thus, from 1 and 2 we can write 24 divided by 6 plus 2 is not equal to 24 divided by 6 plus 24 divided by 2. Thus, we can say division is not distributive over addition for integers. Why we are writing addition here? Within the bracket we are using addition. Next, we are going to check the distributive property for subtraction also. Okay, let us check children. See here, we have taken 3 integers 20, 10, 5 and 2 operation, division and subtraction. First we are evaluating the numbers within the bracket. 10 minus 5 is 5. That is 20 divided by 5. 20 by 5. 1 5 is 5. 4 5s are 20. 4 by 1. 4 by 1. It can be written as 4. Let it be equation number 1. See here, we are distributing this division over subtraction. That is 24 divided by 10. Minus 24 divided by 5. 20 divided by 10. That is 0 0 cancel. 2 by 1 can be written as 2 minus 1 5 is 5, 4 5 is 20. That is minus 4. 2 minus 4. Given two integers are in different signs. So you have to subtract the smaller number from the larger number. You get minus 2. Let it be the equation number 2. By comparing 1 and 2, we can easily say that 20 divided by 10 minus 5 is not equal to 20 divided by 10 minus 20 divided by 5. Thus, we can easily say division is not distributive over subtraction for integers. Okay. Next, we are going to see identity for division. What is the additive identity? 0. If you add any number with 0, that is 3 plus 0 or 0 plus 3, you get the answer 3 only. Similarly, we can't find such number. That is, if you divide any number by an identity element by any number, we can't get that same number. We can't find the such number as an identity. So we can say no identity for division of integers. So whenever in the case of we can't find identity means we cannot define the inverse of the division of integers also. So in the case of division, we can't find identity and also we can't find inverse. Thus, for the properties of division, it does not hold any property. That is closure, commutative, associative, distributive, identity, inverse. Thus, the operation division for the case of integers, it does not hold any properties. Okay. Let us see some problems from exercise 1.2. Let us see the exercise problem, children. Exercise 1.2, fifth sum, subdivision B. Read the question. Give me a counter example using minus 9, 3 and 6 to check if division is distributive. Already we know that by the properties of division is not distributive. Okay, now we are going to check it. Okay, see here. We are taking the integers minus 9, 3 and 6 as like this. Minus 9 divided 3 plus 6. Here we are taking addition only. Don't write the proof for subtraction. It is enough to be addition only. Okay. Minus 9 divided by 3 plus 6. First we are adding these numbers within the bracket. 3 plus 6 is 9. That is minus 9 divided by 9. Minus 9 by 9. So cancelling we get minus 1 by 1 which is equal to minus 1. Let it be equation number 1. Now we are going to distribute this division over the addition. That is minus 9 divided by 3 plus 6. We can write it as minus 9 divided 3 plus minus 9 divided minus 9 divided 6. Let us check whether it is equal or not. Okay, see here minus 9 divided by 3 can be written as minus 9 by 3. If we cancel, we get minus 3 plus minus 9 divided by 6. So by cancelling the 3 table, we get 2 times 3 times. That is minus 3 by 2. See here, minus 3 plus minus 3 by 2. Here it is fraction, here it is integer. So we have to change the denominator as 2. So you have to multiply the numerator and denominator by 2. That is minus 3 into 2, 1 into 2. You get minus 6 divided by 2. Here you have to use the bracket. Okay. See here, minus 6 by 2 plus into minus 3 by 2. It's clear, children? Now see here, minus 6 minus 3, because the denominator are same. So we can add the numerator, minus 6 minus 3. So you get the answer minus 2, minus 9 by 2. Let it be equation 2. See here, the equation 1 we get minus 1, but in the equation 2 we get minus 9 by 2. Thus from 1 and 2 we can say 9 divided by 3 plus 6 is not equal to minus 9 divided by 3 plus minus 9 divided by 6. Thus we can say division is not distributive. Okay. Next we are going to see some example sum. This is example 31. Very easy sum, children. 5 into minus 4 into minus 6 divided by minus 3. Now we are going to cancel this minus 6 by minus 3. First minus getting the answer. 1 3 is 3. 2 3s are 6. So what are the remaining numbers? 5 into minus 4 into 2. Already the minus is cancelled, so you have to write 2 only. So 5 4s are 20, 22s are 40. So plus into minus into plus minus. So your answer is minus 40. It's clear, children? Next we are going to see the sum 11 from exercise 1.2. Read the question. Poonam is asked by her cousin. Cousin means uncle's daughter or uncle's son, like that. Okay? Poonam is asked by her cousin to deliver a box of 20 chocolates. The box contains 20 chocolates. That is, Poonam have to deliver that box to this friend of his cousin. Okay? Poonam is promised a reward of rupees 3. Suppose if you deliver the chocolate, means for each chocolate she will be rewarded by rupees 3. Okay? And also she has a fine of rupees 6 for every chocolate that she eats on the way. Suppose while going to meet the friend, she eats some chocolate, means for that she have to pay the fine for each chocolate rupees 6. Okay? Poonam eats 5 chocolates. On the way, she ate how many chocolate? 5 chocolate. And delivers the rest. Rest means remaining chocolate she delivered to the friend of his cousin. Now what is the question is, how much money will she receive from her cousin? Okay, let us see the sum. What is the number of chocolates in the box? 20. Okay. Reward for every chocolate she delivers is rupees 3. So you have to write it as reward amount is rupees 3. Okay. Fine for every chocolate she eats on the way is rupees 6. These are the given data. Now we are going to find the answer for the question. Okay. See here. Number of chocolates Poonam eats. That is, she eats how many chocolates? 5 chocolates. So you have to write here 5. Now, what is the number of chocolate remaining? Totally the box contains 20 chocolates. Now the Poonam made 5 chocolates. So the remaining chocolate is 15. Thus 20 minus 5 equal to 15. So Poonam delivers only the 15 chocolate to his cousin friend. So how can we calculate the reward amount? She delivered only the 15 chocolate. What is the reward amount? Rupees 3. So you have to calculate the reward amount by number of chocolates by rupees 3. So 15 into 3 is rupees 45. What is the fine amount? The fine amount is calculated by the number of chocolates what she ate. 5 chocolates she ate. So you have to multiply this number of chocolate by fine amount is rupees 6. That is 5 into 6 is rupees 30. Thus she have that money rupees 45 as a reward, but she ate 5 chocolate. For that she have to pay the fine rupees 30. So totally she received the amount rupees 15. We get this amount by subtracting this 30 from 45. We get 15. Thus we can say amount Poonam received from her cousin is rupees 15. It's clear, children? See the example 27, children. On a day in Manali, the temperature was minus 5 degrees Celsius at midnight. what is the time? 12 a.m. It kept increasing. It means here temperature. It kept increasing. That is the temperature kept increasing 1 degree every 2 hours. Okay. After the 12 a.m. for every 2 hours, the temperature is decreasing by 1 degree. Okay. Till 6 in the morning. That is up to the 6 o'clock in the morning, the temperature is for every 2 hours it is increasing by 1 degree. Okay. Thereafter means after 6 o'clock, it is increased by 2 degrees Celsius every hour. That is for every hour means 1 hour. For every 1 hour, thereafter, that is after 6 o'clock, the temperature is increased by 2 degrees Celsius. Okay. Now what is the question is, what is the temperature at 9 in the morning? That is in the 9 o'clock, what is the temperature? That is we are going to find. Before seeing the solution part, see here children, this is for understanding purpose I have drawn this line. See here, this is the midnight. At midnight, what is the temperature they have told? Minus 5 degrees Celsius. I write only minus 5, okay? Minus 5 degrees Celsius at 12 midnight, okay? After every 2 hours, the temperature is increasing by 1 degree. So, after 2 hours from 12 is what? 2 o'clock. Therefore, by 2 o'clock, what is the temperature? How can we calculate? By adding 1 degree with this minus 5. That is minus 5 plus 1 degree. What is the answer? The given integers are in different signs. So, you have to subtract the smaller number from the larger number. So, you get minus 4 degrees Celsius. It is the temperature at 2 o'clock. Okay. After 2 hours, every 2 hours it is increasing by 1 degree up to 6 o'clock. So after 2 hours from 2 is what is the time? Yes, 4 o'clock. What is the temperature at 4 o'clock? How can we calculate? By adding 1 degree with 2 o'clock degree. What is the 2 o'clock temperature? Minus 4 degree. So you have to add 1 degree with this minus 4. You get minus 3 degrees Celsius. This is the temperature at 4 o'clock. After 2 hours from 4 is 6 o'clock. 6 o'clock, what is the temperature? You have to add 1 degree with the temperature in before 2 hours. What is the before 2 hours? 4 o'clock. The temperature is minus 3 degrees Celsius. So add 1 degree with minus 3 degrees Celsius. You get minus 2 degrees Celsius. Thus, by the morning 6 o'clock, you have minus 2 degrees Celsius. It's greater than. See, now read the question once again. Thereafter means after 6 o'clock. Thereafter, heat here represent temperature. Temperature increased by 2 degrees Celsius. In this hour, the temperature increased by 1 degree. Hereafter, the temperature is decreased by 2 degrees Celsius. But in every hour, every 1 hour, the temperature is going to be decreased by 2 degrees Celsius. It's greater than. Now, what is the temperature at 7 o'clock? So, the temperature at 7 o'clock can be calculated as by adding 2 degree with the temperature at 6 o'clock. So, minus 2 plus 2 will cancel. So, the temperature at 7 o'clock is 0 degrees Celsius. It's greater than, because in the question they have told for every 1 hour, the temperature is increased by 2 degrees Celsius. So, we are adding here by 2 degrees Celsius. Here they told for every 2 hours, the temperature is increased by 1 hour. So here we are adding 1 degree Celsius. Okay. See here. What is the temperature at 8 o'clock? How can we find it? The temperature at 8 o'clock can be found out by adding 2 degree with 0 degree. So 0 plus 2, your answer is 2 degrees Celsius. Thus the temperature at 8 o'clock is 2 degrees Celsius. What is the temperature at 9 o'clock? It can be found by adding 2 degree with this temperature at 8 o'clock. That is, here is 2 degrees Celsius. So 2 degrees Celsius plus 2 degrees Celsius, we get 4 degrees Celsius. Thus, the temperature at 9 o'clock is 4 degrees Celsius. Okay. This is the way I am explaining the question to understand you easily. Okay. Now we are going to write the solution for this question. In the exam, you no need to write this number line. Okay. You have to write the solutions only. See here, temperature at 12 a.m. is minus 5 degrees Celsius. Okay. Temperature increasing by 1 degree Celsius. 1 degree Celsius every 2 hours. That is, for every 2 hours, the temperature is increasing by 1 degree Celsius. We just writing what are the given data. Now we are going to calculate temperature at 2 a.m. How can we calculate? By adding 1 with minus 5 degree, we get minus 4 degree. Now the temperature at 4 a.m. Why we are writing 2 and 4? Because for every 2 hours. Okay. 4 a.m. can be calculated by adding 1 degree with minus 4. We get minus 3 degree. What is the temperature at 6 a.m.? By adding 1 with minus 3 degree Celsius, we get minus 2 degree Celsius. Thus, after 6 a.m., the temperature is increased by 2 degree for every 1 hour. That is every hour. Thus, we can calculate temperature at 7 a.m. as minus 2 degree Celsius. This is temperature at 6 a.m. plus 2 degree Celsius. Why we are putting plus here? Because the temperature is increasing. So, we have put the symbol plus. So, minus 2 plus 2, your answer is 0 degree Celsius. Now, the temperature at 8 a.m. is you have to add 2 degree with 0 degree. So, you get 2 degree Celsius. Now, we are going to find the temperature at 9 a.m. is 2 degree Celsius plus 2 degree Celsius. This 2 degree Celsius is temperature at 8 a.m. Finally, we get 4 degree Celsius. Thus, we have calculated in the place modeling the temperature at 9 in the morning is 4 degree Celsius. Next, we are going to see example 30. See dear children, this is very important sum. In the 6th standard itself, you have done this model sum. Okay. What are the types of brackets we have? I already told vinculum, simple bracket, curly bracket and square brackets. And what is the mode of operation we are opening? First you have to use evaluate vinculum, second simple, third curly bracket, fourth only square brackets. And what is the rule for operating this operation? That is Bodmer's rule. You have already studied this rule in the 6th standard. What is Bodmer's rule? First you have to evaluate bracket. And bracket should be operated by this order only, and then half, and then division, and then multiplication, and then addition, and then subtraction. Explain children. Now see the question. We have to evaluate this. See the question. This question contains 3 types of bracket: simple bracket, curly bracket, and square bracket. By the rules of using the operation of types of bracket, first you have to use simple bracket, that is 14 minus 20 first. What is the 14 minus 20 answer? Minus 6. Thus, write the remaining number as it is. 9 plus 7 minus 11 minus 14 minus 20 is minus 6 plus 2 minus 23. Next, thus we have evaluated here, we don't have vinculum. Thus, we have evaluated the simple bracket. Next, we have to evaluate the curly bracket. Listen carefully. 9 plus 7 minus 11. Now we are going to remove this bracket. Minus into minus plus 6 plus 2 minus 23. Now we are going to evaluate this bracket. 9 plus 7 minus given integers are in same symbol. So you have to add 11 plus 6, 17 plus 2, 19 minus 23. Thus we have evaluated the curly bracket. Once again, I am writing this step here. Okay, for your understanding. 9 plus 7. Now we are going to remove this curly bracket. So we get minus 19 minus 23. Thus we have evaluated the simple bracket, curly bracket. Next we are going to evaluate the square bracket. Okay, within the square bracket we have 3 integers: 7 minus 19 minus 23. These 2 integers are in different sign. So you have to subtract the smaller number from the larger integer. You get minus 12. That is 7 minus 19 is minus 12. We can also evaluate these 2 integers also at first. Okay, both are given the same answer only. Minus 12 minus 23. The given integers are in same set. So you have to add it and the result get the same set. Thus minus 35. Now we are going to remove the bracket. Plus into minus minus 9 minus 35, which is equal to minus 26. Thus we have evaluated this all this term and we get the answer minus 26. It's clear children? Next children, we are going to see example sum. Example 34. Read the question. Evaluate 50 into minus 5 plus 540 divided by 100 minus 80 minus 20 into 2. See these sums children. You have all the types of brackets and all type of operations you have. So you have to use the BODMAS rule. What is BODMAS rule? BODMAS. That is B for brackets, O for off, D for division, M for multiplication, A for addition, S for subtraction. So first step is you have to evaluate the brackets. You know already that how to operate the types of bracket. First you have to operate vinculum and then simple bracket and then curly bracket and then square brackets. Observe the question, children. You have except the vinculum, you have simple, curly, square in the question. So first step is you have to evaluate the simple brackets. So within the simple bracket you have 20 into 2. So multiply 20 with 2 you get 40. Thus return 50 into minus 5 plus 540 divided by 100 minus 80 minus 40. Now we are bringing this 40 outside the bracket. Thus we get 80 minus 540. See the next step. 50 into minus 5 plus 540 divided by 100 minus 40. Thus we have evaluated the simple bracket. Next we are going to evaluate the curly bracket. Within the curly bracket we have 80 minus 40. We have already get the answer 40. Now we are bringing this 40 outside the bracket. So you get 100 minus 40. Thus 50 into minus 5 plus 540 divided by 100 minus 40. Next we are going to evaluate the square bracket. Within the square bracket you have 100 minus 40. What is the answer? Yes, 60. Thus 50 into minus 5 plus 540 divided by 60. So next we are going to see the BODMAS rule. Thus we have completed the bracket. In the question we don't have off. So we go to the division. Here what is the division? Division between two numbers, that is 540 and 60. So divide 540 by 60. 0 0 cancel. 1 6 is 6, 9 6 are 54. So you get the answer 9. Thus we have completed the division. Next you have to go for the multiplication. Multiplication is between 50 and minus 5. Multiply the symbol first. Here you have the symbol plus. Plus into minus, minus. 5 by 25, add the 0. Thus you get minus 250 plus 9. Thus we are following the BODMAS rule. Up to multiplication we have finished. Next we can do the addition and the subtraction simultaneously. Here we have two integers. One is negative, one is positive. So as per the rule 2 you have to subtract the smaller number from the larger number. You get 241 and the result get the symbol of the larger number. Thus you have minus 241. Next we are going to see an example sum. Example 35. That is for his birthday Raman. That is Raman is celebrating his birthday. For his birthday he bought 65 chocolates, 54 cookies and 40 pens. Okay. How will he distribute them among his 20 classmates so that everyone gets the same number of chocolates, cookies and pens? Also calculate the number of chocolates, cookies and pens still left with Raman. Do you understand the question, children? That is Raman is celebrating his birthday. Behalf of his birthday he gives treat to his friends. There are how many friends he have? 20 classmates he have. For his classmates he bought 65 chocolates. How many chocolates? 65. How many cookies? 54. How many pens? 40 pens. Now he is going to distribute all these things to his classmates equally. And what is the question is, we have to find the how many number of chocolates, how many number of cookies, how many number of pens is Raman is going to give his classmates. The share should be equal at the same time. And another question is, we have to find the number of chocolate, cookies and pens still left with Raman. Okay. Now we are going to evaluate this sum. Very easy sum, children. We have already know the relation between dividend, quotient and the remainder. What is the relation? Dividend equal to quotient into divisor plus remainder. By using this relation, we are going to evaluate this sum. Okay. First, we are going to write what are the number of classmates in the Raman. Number of classmates of Raman is 20. How many chocolates he bought? 65. So number of chocolates equal to 65. To find the share of each classmate, you have to divide the 65 by 20. So divide the 65 by 20. 3 20s are 60. The remainder is 5. Now by using the relation, we can write 65 as quotient into divisor. 3 into 20 plus 5. You get 65. See here, children. Now we are going to write the what is the share of each student. Each student will get, you have to write the portion number, that is 3 chocolates. For 20 students you are giving 3 chocolates, means 20 into 3, 60 chocolate. Totally you have 65. So subtract the 60 from 65. What is the remaining? 5. Thus we are writing the remainder as the remaining chocolates. Thus remaining chocolate equal to 5. So to write the each share, you have to write the portion. For remaining, you have to write the remainder. Okay, it's great. Let's see the next one. Number of cookies. How many cookies he bought? 54. To find the each share, you have to divide the 54 by number of classmates. That is by 20. 2 20s are 40. Subtracting 40 from 54, you get the remainder 14. So each student will get how many cookies? Yes, you have to write the portion. 2 cookies. 2 into 20, 40. Subtract the 40 from 54, you have already found out 14. Thus, the remaining cookies with Raman is 14. It's great, children. See the next one. Number of pens. How many pens he bought? 40. Divide the 40 by 20. It's very easy. If you divide, you get the remainder 0. Thus, each of his classmates get 2 pens and here no pen with him. That is, remaining pen equal to 0. It's great, children. Up to this sum, we are finishing this chapter integers, children. Okay. And this is we are going to discuss your homework sum. See here, exercise 1.2, 12th sum. I shortly wrote the question, children. That is, Shika have 42 pencils and she is distributing that 42 pencils to his classmates. That is, among his 7 classmates, she is distributing that pencil. For each of his classmates, she give 5 pencils. Do you understand? For each of his classmates, she gave 5 pencils. And the question is, find the number of pencils left with Shiksha. Okay, how do you find? To find the number of pencils she distributed is, you have to multiply the 7 with 5. So 5 7s are 35. So multiply the 35 with 42, you get the remaining pencil with Shika. Okay, see the next question. Arun is also celebrating his birthday. He gave the treat to his friends. Among his friends, 4 friends ordered ice cream. And the cost of each ice cream is 12 rupees. And among his friends, 5 friends choose juice to drink. Okay, and cost of each juice is 8 rupees. What is the question is, how much total money that Arun spent for his birthday treat? That is, we have to find the total bill amount. How can you find? The cost of one ice cream is 12 rupees. How many ice creams he will order? 4 friends. So 4 into 12, you find the amount. How many juice he will order? Only 5 friends choose the juice. So you have to, he ordered 5 juice only. So 5 into 8, you get one answer. By adding the numbers, you get the total amount spent by Arun on his birthday treat. Okay? I hope you all understand all the questions. Write the class up neatly. Do the homework sum clearly. I will see you in the next class with new chapter. Thank you, children. My dear students, in today's activity, we are going to discuss about real number system. Where we get the numbers, we are getting the number from this real number system. See the chart, children. The real numbers are mainly divided into 2 divisions. One is irrational numbers and another one is rational numbers. Inside the rational numbers, it means rational number consists integers. Similarly, integers contains whole numbers. Similarly, whole number contains natural numbers. So, the entire real number system consists all the number system. They are irrational numbers, rational numbers, integers, whole numbers and natural numbers. Let us discuss the number system one by one. First, we are going to see about natural numbers. What is meant by natural numbers? The another name for natural numbers is counting numbers. That is, natural numbers are defined as the counting numbers or positive integers also. The natural number start from 1. So, 1, 2, 3, 4, 5, etc. This collection is said to be natural numbers. The symbol we are using to denoting the natural number is capital N. So, natural numbers, its another name is counting numbers, and N equal to set of all 1, 2, 3, 4, 5, etc. Next we are going to see whole numbers. Whole number consists of natural number and 0. It means if you add 0 with natural numbers, you get whole numbers. Natural number start from 1, 2, 3, etc. It was going on. Whole numbers start from 0. Yes. Thus the whole numbers are 0, 1, 2, 3, 4, 5, etc. It was going on. You are seeing the number line representation of whole numbers. To represent the whole numbers, we are taking the ray because ray has one end point and another side extends endlessly. Similarly, whole numbers start from 0 and it extends on another side endlessly. That's why for denoting the natural number and whole numbers, we are taking the ray as a number line. So what is meant by whole numbers? Whole number start from 0. So we can say W. W is the notation for representing the whole numbers. So capital W equal to set of all 0, 1, 2, 3, etc. are said to be whole numbers. See here children, what are you seeing? You are seeing number line representation of integers. So integers contains negative numbers, 0 and positive numbers. We can also explain it as negative integers, 0 and positive integers. What is meant by positive integers? 1, 2, 3, 4. It means the natural number only. So 1, 2, 3, 4, etc. are called positive integers. What is meant by negative integers? Minus 1, minus 2, minus 3, minus 4, etc. are called negative integers. So along with these two type of integers, if you add 0, we get integers. It means integers contains negative integers, 0 and positive integers. Also we can explain integers contains negative numbers, 0 and positive numbers. Also we can explain integers as it contains negative integers and whole numbers. Okay. And note that children, 0 is neither positive or negative. It is a neutral number. Okay. So what is the symbol for integers? Capital Z. So capital Z equal to etc. minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. This set is said to be integers. See this arrow diagram children. First you are seeing real number system. It is mainly divided into rational numbers and irrational number as I said earlier. And then rational number is extended into integers and integers is extended into whole numbers. And then inside the whole number we are seeing the natural numbers. The symbol for natural number is N. And the symbol for whole number is W. The symbol for integer is Z. So N equal to 1, 2, 3, 4, etc. W equal to 0, 1, 2, 3, etc. Z, that is integers, which is equal to set of all, etc. So before that you have to put etc. and then write the negative numbers. Okay. Minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. Okay. In the next activity we will discuss about rational numbers and irrational numbers. So in this activity, what you have learned? The real number system. Among the real number system, in today's activity, we have detailedly discussed about natural numbers, whole numbers and integers. Okay? Thank you children.